In the previous step, we have configured the light router instance to route traffic to all 4 services we have built. It is recommended, like for every application or every consumer, you have a router instance or a cluster of the router instances. In this case, the router is designed for consumers. Every consumer should have a router instance, at least. For most enterprises, they have existing services already. To bring those services into the light-4j ecosystem, it's easier we just set up a light-proxy in front of these legacy services so that the light-proxy can address all the cross-cutting concerns. And to start the light proxy, let's create another folder and a light config test repository. Within this light config test, we create a proxy folder, and then we copy everything from a service folder. We need to make some modification here. First, we need to disable the console registration for the transactions service. So if we look at the values.yaml, you can see enable verifications true, dynamic port, we change this to false, enable registry, change to false, and verify hostname, change to false. So we don't need register the transaction service to the console anymore. We also need to modify the proxy instance configuration in the proxy folder. Since we don't have any configuration file in the proxy source code, we need to add more config files into this folder. Now let's walk through the config files. We need client.yaml and client trust store in order to connect to the console server. The client.trust store contains the console certificate. We need console.yaml in order to connect to the console. We need handler.yaml. Take a look at this handler.yaml. We added the transactions path to the handlers.yaml so that the proxy can handle those 2 paths on behalf of the service transaction service. We have OpenAPI YAML copied from a transaction service so that we can do the validation and the security based on the specification. Transactions and the transaction, yeah. We also need the proxy.yaml. This proxy.yaml using HTTP2 and HTTPS. The host, the backend host is this 38.113.162.52.8443. Because we start the transactions API using the default server configuration, which is listening to 8443 for the HTTPS port. We need a server key store to get the certificate for the server, and we probably don't need the server trust store if you don't use two-way SSL. Server.yaml, you can see we are using 8080 as default. Sorry, 8443 is default. And we are using the transactions service as service ID here, as the default service ID. For service YAML, we have definition for the registry, console client, load balance, and cluster. Values.yaml. Basically here we overwrite the service ID, and we enable the registry. We use dynamic port, and verify host equal to false, and we enable the security to true. Here, for the OpenAPI validator, we skip the body validation to true, so that we don't validate the body of the request. Because if we parse the body, then we need to deserialize and serialize again in order to send to the downstream API. That will be very slow. So we skip the body validation. So those are the config files for the proxy server. If you go to the proxy folder, you can see we made some modification for the Docker Compose. Previously, we only have 4 services in the Docker Compose. Now we have accounts, balances, parties, and then we have proxy here. The proxy using the proxy folder for configuration. Then we have transactions here. So we basically added proxy in this compose file. When the services are all started, the proxy will register itself on behalf of the transactions to the console, so that from consumer perspective, they will treat proxy as just like the transaction service. In this case, nobody knows there is a transaction service, but they can just access it through the proxy. The proxy is just work on behalf of the transactions. In the next step, we're going to enable the distributed tracing so that we can have a view during the runtime for all 4 different services. Bye.